Okay? Functions can be written with functional notation, in functional notation. F of x, which reads f of x. So that is a notation. And what is that a notation for? It's another way to write y. Now, why would I write functional notation as f of x instead of y? Well, there's two reasons. First reason. The first reason is if I am graphing and I have two different graphs. Say my first graph is equal to y equals x squared minus 5. And my second graph is equal to y equals negative x squared plus 4. Okay, these are the two graphs. Now, if I ask you and I wanted to subtract the two functions, which is something you're going to do in higher level mathematics, divide the functions, subtract the functions, do all sorts of things with functions. How do I know, if I'm going y divided by y, how do I know which one is which? Functional notation is a way of writing it so we know which one is which. So instead of y, we write f of x. F of x, why did they choose f? It's a function, and all y equals equations are functions. Just why your calculator, Kaiser, it's why your calculator has a y equal button. It only graphs functions. It has to be y equals. Now, what do you do with f of x if f is taken? Want to take a guess? Different letter. And they technically usually just go on to alphabetically. So after f is taken, so this would be g of x. If g of x was taken, the other one would be h of x. Now, I can do lots of things. I could take f of x and divide it by g of x. And I know which equation we're talking about. Okay? There's also another benefit, is that the x is on the inside here. And so if I ask you to find f of 2, what that means is I'm saying when x is replaced, what is 2? Yeah, or what is y? When x is 2, what is y? Because the x, we're replacing the x with 2. And part of the reason why we do this is it's a notation. So it's not a variable, it's a way to write y. Okay, so let's go back to our question. Here's a graph. Now my graph is not as clear as your graph. Mine kind of looks not as nice. And it says find the value of y at the given value of x for the following graph. So when it says find f of 2, what that means is find y when x was replaced with 2. What that means is find y when x was replaced with 2. Okay, that's what that means. Find y. And so this is my input, f of x. My input is my x, and out comes our y. So when we put in a value of x equals 2, out pops the value of y. And so in a graph, if I'm inputting a value of x of 2, what's my value of y? It's actually, sorry, the graph is not very nice. It actually is, if you look on yours, it actually is 5. So when I put in x is 2, out comes in our function at x equals 2, it's equal to y is equal to 5. So f2 equals 5. So what that means is when x is 2, y is 5. Yes. There'll be an equation, and we'll do that next. Okay, so next one, f of negative 3. What does that mean? What's been replaced? If the x is replaced with negative 3. So when x is replaced with negative 3, so now my x is replaced with negative 3, I'm pretty sure it's 10. It's definitely 10. Okay, I know for a fact it's actually 10 because I know the equation. So sorry if your graphs aren't clear, but it's 10. Okay, now, next one, find f of 0. So when x is 0, what's y? 1. 1. Okay, now what does this mean? F of x equals 5. Kind of. Now who do they give us? Y. F of x is y. So they give us what they say. They give us the output, and we're trying to find the input. So it's when y equals 2 or 5, what is x? So now they give us the output. They say the output equals 5. Uh-oh. When y is 5, there's two different values for x. What are the two values? Negative 2 and 2. So f of 2 equals 5 and f of negative 2 equals 5. Right? So there's two x values that would give you the output of 5. Okay, so moving on. If they don't give you the graph, then we can solve for it algebraically, as long as they give you the equation. So if they give us that, they said, okay, the equation is f of x equals x squared plus 1. And they said, find f of 2. Find f of 2. So what happens is, well, remember we said what that means is x is replaced with 2. So wherever I see an x, we're going to replace it with 2. So if we're given an equation, it's just replacing our x with 2. So I'm going to go f of 2 is equal to, so wherever I see x, and whenever we replace, we put it in brackets. 2 squared plus 1. What is 2 squared? 4 plus 1 is 5. So f of 2 equals 5. So we just replace it in the equation and sub it in. Easy peasy. So let's practice, well, it takes practice, getting used to the notation. That's like the weirdest part. Just getting used to it. It's really not that bad once you practice. Like anything with repetition, becomes second nature. So let's look at this now. So the first one, f of 1 equals, so they give us the input of 1. Who is the input always? X or y? X. They give us the x, we're looking for y. So they give us when x is equal to 1, what is y equal to? When x is 1, what's y? 0. Got it? No? Okay. So now the next one, who do they give us? Oh, uh-oh. Uh-oh. Well, there we go. Okay, there we go. Okay, so they give us the y equals 3. So when y is 3, what's x? When y is 3, x is negative 3. Try the next one. Think. No, yeah, 0. Okay, number 1. So they give us x. When x is 1, what's y? No, just 4. Just 4. When x is positive 1, y is 4. Okay, 1.5. They give us the y now. Alex? Okay, so now they give us when y is 1.5, what's x? 0. X is 0 when y is 1.5. Next guy, f of 1. So when x is 1, what's y? Negative 1.5. Okay, and last, when they give us y is negative 1. So y is negative 1 here. What's the value of x when y is negative 1? At, 0.5. Okay, moving on. Want to try this one on your own? Try this one. Okay, so when my input is 2, when x is 2, what are the y values associated with x equals 2? 2 and negative 2. So you could write that as plus or minus 2. When our output is negative 1, where does the graph cross when y is negative 1? When x is also negative 1. Okay? It's just like back in, the olden days and you're looking up coordinates on graphs. Kind of. Just written in a weird way. Okay, next guy. F of 4. So what do we have? What do we know? X or Y? X. So when x is 4, so at x equals 4, what are the y values that the graph touches there? 5 and comma negative 1, or negative 1 comma 5. Same idea. When our y value or output is 1, positive 1, what are the x values associated with negative 5 and positive 5? Plus or minus 5. Okay. Next one, when x is 1, so when our x value is 1, our y value is 3. Okay, and one more. When x is negative 1, or sorry, y is negative 1, we have our output. Our x value associated with that is negative 3. Right, when your y is negative 1, x is negative 3. Is that okay? Yeah? Okay. Okay, let's try this. So now we're going to do algebraic. So given that f of x is equal to 2x squared plus x minus 5, find f of 2. How about when I find that? Just insert 2 for who? X, every single x we see. So wherever I see an x, we're going to sub it in as 2. Could we just type that into our calculators? Beep, boop, beep, boop, beep, boop. Okay, if you have your graph up, how do you get out? You could just push the clear button, or second mode will quit. So 2 ways you can type this in. Whenever we sub in a number, keep it in brackets, because if you have negatives in there, it could really change things. So 2 times 2 squared plus 2 minus 5 equals 5. Or the other way we can type it in is we store x, so 2 stores x, and then type in 2x squared plus x minus 5. Both would work. So f of 2 equals 5. Okay? And so that's nice, is because it translates as a coordinate. That's 2 comma 5 as the coordinate. Okay, next guy, what are we going to do? Sub 0 for each x. So f of 0 equals 2 times 0 squared plus 0 minus 5, which is just minus 5. Because 2 times 0 squared is 0, plus 0 is 0, minus 5 is negative 5. Okay? Try f of negative 3 on your own. Try f of negative 3. So sub it in, find out what it equals. there's one on my desk. Okay. That. Should be no x in there. Should just be a squared right here. Should be squared. There you go. It's 10. You should be getting 10. So 2 times negative 3 squared plus negative 3 minus 5 gives you 10. 10. So f of negative 3 equals 10. It's very easy when we're solving for the y. Yes. Yes. Yeah. Okay, E. Sometimes our x is replaced with a variable. That can happen. So now what are we going to do? Is that change our process, or are we going to still do the same thing? Same thing. Wherever we see an x, we're now going to write 2a. So f of 2a is equal to 2 times, so instead of x squared, we're going to write 2a squared. Because we're replacing wherever we had an x before, I'm going to put a 2a. Plus, and that's why we also need brackets when we replace. Okay, it's very important that we have brackets when we replace. So wherever we see an x, we put 2a. Now, obviously, you're not going to get a number answer because there's a variable in here. We're just going to simplify this. So what can we simplify here? What can we simplify in this process? 2a squared. What is 2a squared? 2a times 2a, which equals 4a squared. 2a times 2a is 4a squared. What else can we simplify now? 4a squared times 2, what does that equal? 8a squared plus 2a minus 5. We don't have like terms, so we're done. So our original function was f of x equals 2x squared plus x minus 5. Wherever we saw an x, we replaced it with a 2a. So I replaced all the places we had an x with a 2a. Okay, we're going to change the last question. Given, can you write this out? Given f of x equals 2/3 x minus 5. Okay. Oh, let's make it plus 5. Determine x when f of x equals, what did I say? 11. Okay. Given f of x equals 2/3 x plus 5, determine x when f of x equals 11. Who did they give us? The y value, the output. And we are looking for x. So with my equation of f of x equals 2/3 x plus 5, so write out your equation and then we replace. Who are we replacing? Who do we know? 11 is if it equal to f of x. That's who I'm replacing. F of x is equal to 11. We know our output. We don't know our input. We know our y value. We don't know our x. So guess what we're going to have to do? Algebra. Paul, first step. Minus 5. What is 11 take away 5? 6. 6 equals 2/3 x. Okay, so instead of dividing both sides by 2/3, let's just get rid of the fraction first. How do I get rid of the fraction? times both sides by, what's on the bottom? 3. So multiply both sides by 3. The 3's will then cancel out. 3 times 2, pardon me, 3 times 18 equals 2x, and then divided by 2. And we get x equals 9. Now we're not done. Well, they said find x. We did find x. We're just going to write it in functional notation. So f of 9 equals 11. So f of 9 equals 11. Did you want to try another one like that on your own? I think you should. Okay? On the next page, we're going to omit that example. So we're going to omit the example on the next page. And instead, so cross that example off and write this in instead. Where were you? Okay, so try, write this a question down. Okay, I'll put it back later. Yeah, so, if f of x equals 2 times x minus, let's make this interesting. No, let's leave it. Okay, so write that down, please. And then I'd like you to try it. You need to be writing this down. If f of x equals 2 times x minus 3 plus 5, determine x at f of x equals 12. At f of x equals 12. Determine x. Yeah? Question? Ooh, so you want to try this on your own? Okay, so we know our y value. So our equation is f of x is equal to 2 times x minus 3 plus 5. So who did they give us? Y, the f of x. So we're going to replace f of x with what number? F of x equals 12. So we're replacing our f of x with 12. Okay, first step. Yeah, Brayden? Subtract 5. So we have some algebra to do. What is 12 minus 5? So I have 7 is equal to 2 times x minus 3. Now you have two options here. One, you could either go with distributive law, or we have to divide both sides by 2. It's on the outside of the brackets. Distributive law, okay? So 7 equals 2 times x is 2x minus 2 times 3, negative 3, negative 6. So now that we've used distributive law, makes it a lot easier. Now we add 6. What is 7 plus 6? 13 equals 2x, and then we divide by 2, and that gives you 6.5. So or you can leave it as a fraction of 13 over 2. So f of 6.5 equals 12 is our answer. Now, the last thing I'm going to do is work through a couple homework questions with you. Yeah? No. Don't look at your phone. There's either that clock or that clock is your options, okay?
Do the math.
Okay. Please take your textbooks, open up to page 270. 270. Okay, open up to 270 in your textbooks, please. Go back a page. Yes? To here? Okay, so take your textbooks, open up to 270. Please grab your homework books, whatever you do your homework on. And there's 2 homework lessons. Okay, and they're both on lesson on page 270. Okay, so on 270, there's 2 homework lessons. So lesson 2 is the following questions. Did you get it done? Yeah? Okay. So let's go down here. So lesson 2 is the following: 4 to 7, 9 and 12. And lesson 3 is 14 to 16 and 19. Okay, so that's your homework for tonight, all of this. 270, 4 to 7, 9 and 12. So this box right here, you guys have it in front of you. It's in your book. So lesson 2 and 3. Okay, now I'm going to work through number 6 and 7 with you. Okay, number 6 and 7 I'm going to work through with you. So numbers 6 and 7, I've actually already written them on the board. So if you have 270 in front of you, I'm going to work through 6 and 7. So actually, it's going to become 4 to 5 because I'm going to do 6 and 7 with you. Okay? Yeah, it's part of your homework. And it's going to be on the quiz tomorrow. You might want to. So it says write in functional notation. So I need to talk to you about how to do this. When we have a y equals equation, it's very easy to write into functional notation because instead of writing y, what do we write? F of x. So D I would write as f of x equals negative x. I just replaced the y with f of x. That's it. Okay, changing it to functional notation. If the variables are not x and y, instead of using f, we just use the variables given. Okay, so the reason why we have f of x is we're basically saying that y is a function of x. X is the input, y is the output. Y results because of x. So in our first equation here, we have c equals 20n plus 8. So c is a function of n. C is the output and n is the input. So if I want to change that to functional notation, we want to keep the integrity of the original variables. And the reason why is there probably is context to that question, to that equation. And so to write that in functional notation, we just write c of n equals 20n plus 8. So c is a function of n. C of n. That's how we change it. That's how it's done. So in B, we have p equals n minus 3. P of n equals n minus 3. So T of D equals, that's all you have to do to change it to functional notation.
And then the next one would be y.
No, so we don't ever write y of x, and that's when we use f of x, if it's a y. Okay. Here, I'll go like this so this is not distracting me right now. 1 second. 1 second. Don't be scared. Okay. Okay, so now, in number 7, they want us to do the opposite. We're given functional notation, and we're just going to write an equation with 2 variables. We're just reversing. So if my equation is d of t is equal to 3t minus 5, what is it going to become? 3t minus 5. If our original equation was f of x is equal to negative 6x plus 4, it would be y. Remember, f of x is our y, equals negative 6x plus 4. Okay, so f of x and y are interchangeable. Any other variables, we just use those variables. So if we're taking this guy out of functional notation, it would become C equals 5n. And the last one, P of n, P equals 2n minus 7. Okay, easy peasy? I love it. Sorry. Okay, so stop.